All right. So we're gonna work on module. What is this? Module 57 today. We should have just one module after this. So we'll do this today, and then tomorrow we'll have one more lecture, and then you guys will be all caught up with everybody, as I said, and hopefully prepared and ready for the test. Um, Let's go ahead and pray, and we'll get started with this module. Lord God, I just ask that you bless those that are watching this today, that you be with those that are preparing for this AP environmental science test. Lord, help them to do well, help them to achieve, Lord. Help them to just log on effectively, not have any technical issues with that, Lord. I just pray that you be with them in this time. Lord, some of them are longing, I know, because I am as well, longing for summer. May you give them the knowledge, Lord, that as soon as they finish this task, summer will be theirs. Be with us. Bless the summer, Lord, that we have coming upon us. Bless us as we prepare for this test. In Jesus' name I pray. Amen. All right. So I want to talk about the human response to chemicals today and kind of ways in which we study that and what we've learned from that. So those studies. So what we're talking about is the human response. But a lot of times when we do these studies, obviously we're not doing studies on humans because that would be unethical. Um, so what we've learned about response to chemicals is usually from some sort of other organism like Daphnia or mice or anything else that is usually tested on in labs. But I meant to highlight all of the other ones here, but the three types of chemicals that we've classified all chemicals into, at least ones that have ill effects towards individuals, is one, neurotoxins. Just like the name kind of suggests, neuro usually relates to the brain or the nervous system. So these toxins uh, form a toxicity in the body to your neurological system, okay, or your nervous system. Um, so things like insecticides. I don't know if you've ever watched. I guess this is a little bit morbid, but if you've ever sprayed something like a wasp with an insecticide, with a wasp killer, excuse me, and watch what they've done after. They start to kind of like stumble around. And the reason for that is because the neurotoxin that you just dosed them with is a neuroinhibitor. It stops them from being able to communicate with their appendages. And basically, what happens is it paralyzes them and they suffocate. Not a good death. I realize that might make you feel bad, but again, I don't want you guys have all seen the memes right now, like the giant Asian hornets. I think they're Asian hornets. I think that's the name of them. That are invading the United States right now. If one of those things came a knocking, I'm gonna get the wasp spray out, the hornet spray, and I'm gonna unfortunately release some neurotoxin on them. But this is one reason why you don't really want to spray that on yourself, because that kind of impact could, if you sprayed in a large enough dose, could actually impact you. Heavy metals like lead and mercury also are neurotoxins because they interrupt brain activity. So there are little deposits of lead will be trapped inside of the fissures of your brain, and filling in those gaps, it will start to cause lots of issues. Carcinogens are ones that you guys are very familiar with, I assume. These are chemicals that are known to cause cancer, and they do that usually by damaging the cellular tissue and forming what are called mutagens, which lead to uncontrollable cell growth. These are mutated cells, basically, those mutagens. But basically, if you damage your DNA, you are considered a carcinogen because the opportunity for that damaged DNA to cause uncontrollable cell growth, which is cancer, becomes that much more high. Uh, a teratogen, I don't know if I'm saying that correctly or not. Teratogen, I'm not sure. But these are chemicals that um, impact reproduction, and specifically they impact reproduction in the form of affecting the embryos and fetuses. So I guess you can't really say it's reproduction. I guess it's part of it. Um, uh, Thalidomide is an example of this. It is a teratogen. Teratogen. Yeah, there you go. And the reason that it is because this was actually prescribed. I don't know if you know the history behind this drug. It was considered kind of a miracle drug because it would stop morning sickness. So obviously, the first trimester of a woman's pregnancy, morning sickness is a really big issue. It's something that a lot of women experience, and it can be devastating. It can be really, really bad for some people. So thalidomide was prescribed as a cure to morning sickness, and lots of women in the 50s took it. Lots of women. And here's the bad thing. It took us a long time to figure out. It didn't have any effect, any ill effect on all the studies that we did. It had no ill effect on the person that was taking it. However, for the developing fetus, it had devastating effects. It would cause appendages to not develop correctly in the best case, which means that people would develop misshapen arms or legs or feet. And in the worst case, it would kill the fetus. I know someone personally, someone very close to me, whose mother took thalidomide while they were pregnant. This was in the 50s, so she's older. Because of that, she developed club feet, and that's something that she's had to deal with for a long period of time, for her entire life, as a result of that. So obviously devastating effects. Very good that they don't have it on the market anymore. There's again, my friend was very lucky because she lived. There's lots of children that did not live past birth because of the devastating effect of that particular medication. Alcohol use is another good example of this. It's not a good example, it's a horrible example. Alcohol disrupts the development of the nervous system in unborn babies and will cause, at best, alcohol fetal syndrome, and at worst, death. So that's why you should not, by any means, drink while pregnant. Definitely don't smoke either, and don't take thalidomide. All right. So more chemicals kind of continued here. Ones that are probably close to all of us is allergens. These are chemicals that cause allergic reactions within the body. And the way that they do that, your body responds to allergens by releasing histamines, which fight off the allergen. However, they also have sort of ill-desired effects like runny eyes, runny nose, itching. We experience discomfort because of the release of histamines as a response to the allergen that has entered the body. So then you take something called an antihistamine to try and block those effects. So we also have endocrine disruptors. These are chemicals that interfere with the normal functionality of hormones within the body. Hormones are our body's chemical signals. They are one way, and probably the primary way, that the brain tells cells what to do. Okay, so the brain can tell cells what to do through electrical impulse, which is I guess probably the primary way. But there's only certain cells that respond to electrical impulse. Neurons and muscle fibers are really the two cells that do that more than anything else. The other cells in your body don't really care about electrical impulse. So the only other way to kind of talk to them is through chemical symbols, through hormone release. So the endocrine system, is what creates those hormones and releases them throughout the body. The two famous hormones that you guys probably know the most about are testosterone and estrogen. It's a misconception that testosterone is only found in males and estrogen is only found in females. You have both of those. I don't care if you're a male or a female, you have both estrogen and testosterone. If you're a male, you have more testosterone. If you're a female, you have less testosterone. What's interesting is as you age, males will create less testosterone and actually more estrogen. Okay, that doesn't mean that they flip by any means. They don't flip. You still will always create more testosterone as a male and less estrogen, but the amounts go down. So you actually peak as a male at about 18 years old with the amount of testosterone that you produce, and it starts to go down after that, and the amount of estrogen that you produce starts to go up. Females are the opposite. As they get older, usually it's about 30, the amount of testosterone that they make will go up, and the amount of estrogen they make will go down. Okay, so and these control so much. They control your growth. They help control your metabolism, the development of reproductive organs during puberty. All of these things are really important. Now, how are they affected? Well, we release hormones into water, usually in the form of either birth control or growth hormone that we give to animals and livestock to try to get them bigger, and other medications that act similarly to hormones within the body. When you drink that water that's contaminated with that, obviously, or if you live in that water that's contaminated with those hormones, like fish, obviously not you, but fish and frogs and things like that, they're going to have an ill effect on those organisms. And we'll see a lot of reproductive issues primarily with like things like fish. Okay. So those are the chemical classifications. These are the concentrations. This is how we figure out basically what the dose does to you. Okay. And that's through what's called a dose response study. By exposing animals or plants to different amounts of a particular chemical that is the question of a study, and looking for the responses, we better understand the effect the chemical has. So, and we do this both to try and discourage death, but also to encourage it. The reason that Roundup works on plants is because they've done dose response studies. Roundup wants to know the highest death rate for the lowest concentration of active chemical, because that active chemical costs money to produce. So they want to give you the lowest concentration possible that's still effective. Because if it's not effective, if you spray Roundup and it doesn't kill your weeds, guess what you're not going to do when you go back to the store? You're not going to buy a Roundup again. Okay, so they want it's in their best benefit or the best interest to do a dose response study and find the dose that is the most lethal while also the most economical. So that's just one example where they're trying to do that. Most of the time when they do these studies, we're trying to avoid death. We're trying to figure out how much of a particular chemical that might be in the waterways, might be in our food source, that we can actually survive. And they do that through two types of study: acute study and chronic studies. Acute study is where you have exposure to that chemical to an animal in an environment for a short duration. And a chronic study, chronic means a prolonged exposure. And so basically you're getting exposure to that chemical over a long period of time. And that brings us to LD50. LD50 is a really important concept in this field, in environmental science. So I really want you guys to try and understand this. Read through your book, read through this module, because it does a nice job as well of explaining it. But LD50 is the gold standard of measurement. Okay, it's the lethal dose of any chemical that kills 50% of the individuals in their dose response study. So it's the dose that kills half of them. Okay, now why is this important? Well, because we use it as the benchmark for all other chemicals. So it says dose response studies most commonly measure mortality, death, as a response. And they do that by counting. So what they do is they take a group of individuals, let's say it's mice. Well, just to make it easy, everybody knows what a mouse looks like. So let's say they have a group of mice of, let's say, 50 mice. Okay? They expose it to a chemical. I don't know what it is. Maybe it's DDT. They expose it to a chemical, and they're exposing it in relatively high doses because they are trying to find out the lethality of that particular chemical. So they give a high dose of DDT, and they either expose that to it in one burst, or they do it over a long period of time. So it's either acute or chronic. And they wait until 50% of the individuals die, and they know that that is the dose. Like, they might do this several times, so they might give different doses. So they might give one group of 50 mice 1 milligram of DDT to consume per day. In another group, they might give 2. The next group, they might give 3. And they do lots of these trials. And they find out, okay, this is the group. They got all the way up to 10 milligrams. This is the group that 50% of them die in a given period of time. That would be the lethal dose 50, or the LD50. And why is that so important? Why are they looking for that number? Well, that is the benchmark. That is what they compare all other chemicals to. So it's a good thing to know this, because they have a lot of LD50 information for all the chemicals that exist. So when a new chemical comes, they can figure out its lethal dose 50, and they can say, okay, well, this one is much more toxic, because if, like, here's a comparison of another similar chemical. This chemical has an LD50 that's much higher, so the lethal dose is maybe 100 milligrams, where this one is only 50 milligrams, obviously this is a much more dangerous chemical and something that we need to label and classify as dangerous. So again, LD50 is not only a way that we measure mortality rate, but it's also the way that we compare it to all other chemicals. Very important to be able to do that. Okay. We also have ED50. It's not as profound. It's not as important in sort of this world, but it's definitely something that you guys need to understand because and the main thing is that not all chemicals cause death. Okay. Like I said, lots of people, for example, smoke, and now granted that does result in death a lot, but that smoking can cause death, but for the most part, it just causes sublethal effects. Okay, it causes you to have a cough, or it causes you to have, a wheezing or shortness of breath. These are non-lethal or sublethal effects. So ED50 would be the effective dose that causes 50% of the individuals in the study to display a harmful but not lethal effect. Okay, so it's very similar to LD50, except the fact that this is just showing that you actually have been exposed to a chemical that causes an issue rather than causes death. Okay, and then of course you have the last sort of thing here, which is no observed effect level, or NOEL. This is honestly also what we're trying to find. It's very important. This is the highest concentration of a chemical that causes no lethal or sublethal effects. This is the amount that every individual in a population can take. Okay. Now, why is this important? Well, sometimes we need to know this because some chemicals might have a good effect that we want, but in high enough doses, it might have a bad effect. And we need to know kind of where that line is so that we can maybe prescribe medicine to help lower our blood pressure, but not kill the patient that's being prescribed that medication. Okay, it's very important that we understand a dose that is effective in the amount and what we're trying to accomplish, but not so effective in the fact that it's going to cause either a non-lethal or sublethal effect or a lethal effect. Obviously, we don't want that to be the case. So the no observed effect level, or NOEL, is incredibly important. So when it comes to these studies, there's two types. There's retrospective studies and there's prospective studies, and these relate more to people. So these are dose studies that monitor people who have either been exposed to an environmental hazard or going to be exposed to an environmental hazard. So these aren't exactly the same as the as the dose studies that we're talking about here, the dose response studies. These are more, you're taking an individual that you know has either been exposed to an environmental hazard, like someone who lived next to Chernobyl. We've talked about Chernobyl a lot in this class. Obviously, they've been exposed to radiation, so you can study a group of those people to see the effect that radiation might have. Or a prospective study, which is probably the hardest one to study, which is to monitor people who might become exposed to a particular environmental hazard. So these are people that work inside of like a mine, or they work in a dangerous area, or they smoke, where someone can smoke a cigarette and not have any effects. Over time, there might be issues with that. And the problem with these studies, these types of studies, is this idea of synergistic interactions. This is when we take two or more risk factors, and when they're combined together, they are actually much more potent than any other single risk factor on its own. And I have an example over here on the right-hand side. It's tobacco and asbestos. So smoking tobacco gives a particular amount of risk because you're exposing yourself to carcinogens, so there's going to be ill effects because of it. But if you also live in a house that is contaminated with asbestos, you are doubling. Those two together actually form more of an issue than they do separately. And the reason for that is because not only are you breathing in tobacco, and that's damaging the DNA in your lungs, but you're also breathing in asbestos, which is damaging DNA in your lungs. So they are worse together than they are apart. And that's what makes these prospective and even retrospective studies really difficult, because it's hard to determine if an individual is having an effect, an ill effect, based off the environmental hazard or based off one of the other factors that they live with. All right. So all of this, we do a lot of this just to better understand how we're exposed to chemicals and what those chemicals do to us. So it's important, if we're trying to figure out what chemicals do to us, it's important to know where those chemicals come from, how they come into contact with us, how we are exposed. We've been talking about exposure to all of these chemicals. Well, it's good to understand how we're exposed to them and how they get into our systems. So the ways that we look at that, we look at routes of exposure. This is the ways an individual might come into contact with some sort of environmental hazard. Sometimes that's as simple as like, well, you spray Roundup on your lawn and then you go and play outside. You're exposed to that. But sometimes that's much more nuanced. It's much harder to kind of determine. Maybe you work in the automotive industry and a particular compound in a synthetic oil has finally been known to cause cancer, and you've been working with that for 20 years, and we didn't know prior to that that was the case. So again, finding routes of exposure is really important. Once the chemical gets to us, the next question is kind of, how is it being processed in the environment or in us? And one of the things that's important there is solubility. So a lot of times chemicals are found in a solid form, but them being dissolved in liquid, that's how they get into our systems. There was an example of this in the book that talked about a particular compound in plastics and how if it's exposed to infants at a young age, either through toys or through baby bottles, so like milk bottles, it can then become soluble and expose the child to a harmful environmental hazard. And you might question like, well, how is it going from the toys and how is it getting soluble there? Well, babies put things in their mouths, and your mouths have saliva and water in them. So obviously it has an ill effect there. Solubility is important. So bioaccumulation is what happens when you have an increased concentration of a chemical within an organism over time. So things like we talked about lead and mercury, those bioaccumulate. So you might have deposits of lead in your body in really small amounts, and it's not going to affect you at all. But if you continue to expose yourself to lead, it will eventually bioaccumulate, and you get larger and larger amounts in that organism over time. That leads, in some instances, to biomagnification, which is the increase in a chemical concentration in an animal's tissue as the chemical moves up the food chain. So if you have, we'll just take mercury as an example because it's probably the best one. If you have mercury that is being absorbed by phytoplankton in really small concentrations in the ocean, and then you have a small fish like a guppy or something that will come in and eat that phytoplankton, okay, it's bioaccumulating that lead, but it's doing it in small concentrations still, but higher concentrations than the phytoplankton, okay? And then you have a larger organism like a tuna that comes in and eats that larger fish. Again, it's bioaccumulating over time. If you let each one of these fish grow and they're eating every day, they're going to accumulate more and more of that particular hazard, whatever it might be. To the point where you get to the top of the food chain and you're eating food that has a high amount of mercury. This is why, guys, it's recommended that you only eat ocean fish one time a week. It's because of the amount of mercury that's found in it. If you eat more than that, you're going to bioaccumulate mercury at a harmful rate, and it's going to be harmful to you. So, last thing is persistence, how long the chemical remains in the environment. DDT is an interesting example of this. When you spray DDT on a field or even spray it on your skin, wherever that DDT ends up, it's going to stay there. It's going to stay there for 30 years. In fact, after 30 years, it's still half going to be there. Okay, that's its half-life, which means in 30 years, if you spray 2 pounds of DDT onto a field, you're going to be left with 1 pound in 30 years. It's still 1 pound is going to be found in that soil. Obviously sprayed throughout a large area, but still, some chemicals persist very, very strongly. Other chemicals, like sulfur dioxide that comes out of the tailpipe of your car, that's going to float up in the atmosphere. It doesn't have nearly as long of a life as something like DDT. All right. That was all I had for you guys today. I kind of went through it fast. I'm sorry, but it was about 25 minutes. Guys, no homework today, no assignment or anything. I just want you to watch this video. I will have the last video for you out tomorrow. And then, like I said, we'll be done with all of the units. All right. Happy studying, guys. Hope you're doing well on your AP exams, the ones that you don't have for this class. And I hope you're studying for the one that you have on Monday. Talk to you later. Bye.